Hello, and welcome to the tutorial on multi-agent AI systems with CREWAI. Before we actually go into the tutorial, let's first see why are we learning about AI agents. Let's go over some predictions and stats. According to Gartner Inc., by 2028, one-third of interactions with generative AI services will use action models and automation agents for task completion. In the words of Andrew Ng, who is the founder of deeplearning.ai, AI agent workflows will drive massive AI progress this year. It's an important trend, and I urge everyone who works in AI to pay attention to it. As per Forbes, agents are not just another overhyped AI buzzword. They are the inevitable future form for AI systems. Before you know it, you will be interacting with many different AI systems, agents on a daily basis. Things are only going to get weirder and more magical from here. We need no more convincing in order to go about why we are learning about AI agents so you are on the right path. Now let's see what are we going to learn in this tutorial. We are going to see what are AI agents and how are they different from the large language models. We'll go over building blocks of and key elements of the AI agents. Then we'll see what is the mental framework required before we even begin creating the AI agents. Then we'll go to actual projects of writing research articles with multi-agent systems and customer service response to customer queries and understand the workflows in detail. And finally, we'll explore what all extra is possible using the CREWAI. In this whole tutorial, we will use CREWAI as the platform, which is an open source platform for orchestrating and creating the AI agents. So let's dive in. Hello. In this video, we'll see what are AI agents and how are they different from large language models. Let's say we have a goal here to write a blog post about artificial intelligence. We go to ChatGPT, we give a set of clear instructions about the blog post we want, and when we get an answer from ChatGPT, we again give another set of instructions in order to customize the blog post based on our requirements. These interactions may go on for a number of times before we actually receive the final output that we can use as a blog post. Now, how can we reduce these number of interactions with the LLM by using the AI agents? When we give the input to the AI agent using the ChatGPT, for example, then instead of returning the final answer immediately, it goes into what is known as an agent execution chain, which is divided into 4 phases: thought, action, pause, and observation. It will take the task that you have given it, and first it will think through it, that what many subtasks can be derived from that task that you have provided. And it will rearrange those subtasks in the order of priority in which they need to be executed. Then it will take each subtask and decide what action needs to be taken in order to complete that subtask. And after that, it will perform the action and then pause and observe with itself, reason with itself basically, and then in the same way, it will go over a number of iterations in order to give the final answer back to you. Now, let's suppose that we just don't want it to give a blog post. We want actually it to go ahead and post it on LinkedIn, for example. So AI agents also have access to what is called the tools and the memory. Using the tools, the AI agents can perform actions. They can actually interface the outside world, external systems like APIs, databases. They can actually, for example, here this blog post needs to be, published on LinkedIn. Then it can use the APIs of LinkedIn in order to post this particular blog post from your account. Also, to remember all the preferences and the previous interactions, it can use the memory which can be associated with the AI agents. So in all, it becomes like a virtual assistant to you, which has the access and knowledge of all the tools which it requires to perform the tasks, and also the memory in order to remember your preferences and your conversations and your previous, whatever tasks you have executed. All those sort of information is already stored with it. So now you can imagine how much powerful these AI agents can become and you are actually not, the interactions of you and the LLMs have been reduced to mere input and output, and all the background work is now being done by the AI agents. You can also do multiple tasks, not only like, for example, post the one-time posting of the blog post. You can actually schedule, for example, every Monday you schedule posting of the blog on LinkedIn on your behalf. You give a variety of topics already that can be stored in the memory, and it can go ahead and schedule. So there are a lot of opportunities that are open once this format can be implemented using the AI agents. Now, let's see what we just learned in the form of definition, and I think now you can quickly relate to what is being defined here. AI agents are combined systems that achieve defined goals without repeated human intervention, using a variety of AI techniques to make decisions and generate outputs. They also have the potential to learn from their environment and improve over time because they also have the memory and they keep learning from it, enabling them to handle complex tasks. Right? Now let's see quickly what kind of AI agent systems can be made. So again, this was a regular prompting experience wherein we were just multiple number of times we were interacting with the LLMs just to get a response, but there was no action here taken. It was just a normal question answer session. Then we came to this format wherein we have the AI agent thinking through the execution chain and then provided us the answer. The number of interactions here are very limited. Then here it shows that now it has access to the tools to communicate with external systems, external world, and it can make use of all those in order to provide you the best answer possible and also execute the tasks that you have provided. And here it is a more meta AI agent systems, multi AI agent system basically, wherein it is a complex task and it cannot be done by a single agent. Then you employ multiple agents in order to accomplish that task. The input is given to one agent, and the output of one agent is then fed into the other agent, and so on and so forth. And finally, you will be having the complex task done for you with use of multi agents. And when I'm using multi agents, it is not necessary to use only one single LLM every time with each agent. You can actually think of this as you can use expert LLM for that particular task, which can be achieved. For example, here researcher role is actually done by Llama 3 model, and the writer role is done by using GPT-4 model. So we can make use of multiple LLMs and the background in order to accomplish the tasks, which are very focused tasks for each agent, and we can get the best output in this way. And again, this complexity of the applications that can be, or the work that can be done, is like, the huge potential is there, because we can just go on combining these multiple agents in a way that can receive into meta multi AI agent systems, and we can get more way complex tasks accomplished using these AI agents, right? Okay. In this video, we'll go over the building blocks used in CREWAI in order to create multi-agent AI systems. There are three main building blocks in CREWAI: AI agent, task, and crew, and we'll go over them one by one. The AI agent is the brain of the system. In the background, it is connected to an LLM, which is either open source or closed source LLM. The critical attributes which are fed to the AI agent are role, goal, and backstory. The role is what role you want the AI agent to play. For example, depending upon the task, it can be a financial expert or a home expert or a computer, network engineer, or what kind of role you want it to play in order to accomplish that task. The goal is, what is the goal it needs to achieve based upon what inputs you provide. And the backstory is the clear set of instructions that the AI agent should use in order to accomplish this goal. The other key attributes associated with AI agents are, first is the cooperation, which leads to the cooperations between, if it is a multi-agent AI system, they have to cooperate with one another in order to accomplish the final task, which is used by allow delegation, wherein one AI agent can act as a manager or a lead, and it can delegate the work to a sub-agent which can accomplish or complete that task and return the result to the lead or the manager LLM. So this field is provided here in order to allow the delegation to be set for a particular AI agent. And if allow delegation is true by default, if it is set to false, then that particular AI agent will not be able to delegate the work to any other agent. There are separate guardrails which are associated with AI agents. The usual ones are the number of iterations that the AI agent can be, used is limited so that it doesn't go into an endless loop. There is also a time limit which might be set in order to not exceed the maximum time and get stuck in the loop before returning the results. And similarly, there are other policy guardrails and or responsible AI guardrails that are put here in order to fetch the AI results responsibly. The third thing which have access, AI agents have access, are the agent tools, wherein they access multiple. They are the inbuilt CRUD AI tools are there, and also LangChain tools are also accessible through CREWAI AI agents, wherein they can access the external systems and databases and services and all sorts of things using these agent tools. Now coming to the next building block, which is the task, which is nothing but the action that the AI agent has to perform. Now, once you have defined the AI agent, then we will go ahead and define the task that has to be done. And with the task, all information we have to provide. First is the description of the task in the clear manner. What exactly needs to be done with this task? What is the expected output? That also needs to be defined in a very clear manner so that there is no, confusion and there is no fuzziness in the returned output. And then third is the AI agent. Which AI agent is going to act on this particular task? We should have already defined the AI agent before defining the task so that we can give that AI agent as an input to this task. Apart from this, what we also have to give is the task tools if we are using. So, for example, that if an AI agent is already having the tools associated with it, but we have given another tools tasks here, then agent will only use the tools which are defined with the task. So the task tools always override the agent tools, and it can use these tools in order to accomplish the task which has been defined in order to complete it here. Then we can set the context for the task. We can set the callback also for the task once it is completed, and we want the results back to be sent out to another task. Then we can also force human input before returning the final answer if we want the the result to be have looked by a human before returning the final answer. So there is a possibility of forcing the human input here. Then it is also possible for asynchronous execution and parallel execution. Multiple tasks can be executed parallelly and also in an asynchronous manner, like there is no wait for one task to be completed before the other begins. All those sort of possibilities are here. And then it also supports multiple output formats in the form of JSON and Pydantic and output as file. So many other output formats it can provide the results in. So this is the task building block. Then we have the CREW building block, which is actually nothing but the workflow in which these tasks have to be completed. So what will be the input to the CREW? It will be a list of AI agents that we have already defined, and it will be a list of tasks. Now, one thing important to mention here is by default, the execution of tasks is in a sequential manner. So we have to be careful in giving the order in which we are giving the task, because by default, they will be executed in a sequential manner, one by one. But there is another type of process type which is allowed here, which is hierarchical, wherein we can define a manager LLM, and then that manager LLM can delegate the tasks in a hierarchical manner to the AI agents and then receive the result and then finally publish the result. Along with this, we can also define in the CREW the memory, and if we set memory to true, then this particular workflow will have access to the memory. In CREWAI, there are 4 types of memory, which is short-term, long-term, entity, and contextual. In the short term memory, it is limited to the current execution. Long term memory involves or has the knowledge of the past executions as well. Entity is nothing but whatever entities, the person, places, things, etc., have been accessed during the execution. It will take note of those entities and store it in the memory in order to use them in the future references. And contextual memory is overall memory, which is basically combining all the three other memories in order to have a powerful, complex tasks accomplished. Right? So these are the three building blocks which are used in the creation of multi-agent AI systems using CREWAI. Another important component in the CREWAI to be noted is the tools. As explained earlier, tools are the interface of AI agents to the external world. And in CREWAI, there are a list of tools available internally, as well as they have access to the LangChain tools which are available. So if you see on the right hand side, these are the list of tools, not an exhaustive one, which are available using the CREWAI. And if you have a rough glance, you'll see all sort of web search APIs, web search tools, then website scraping tools, then YouTube search, YouTube video search tools, then you have JSON search tools, GitHub search tools, and all those other Selenium scraper for testing, test scripts and all. So these are the wide variety of tools which are supported and are available at hand for use by the AI agents. Another important thing to note about tools is the versatility of the tools, wherein these tools are capable of converting the fuzzy inputs which are often associated with the large language models, wherein we give a mix of numbers and words and text and instructions. So it takes those fuzzy inputs and converts them into strongly typed outputs in order to communicate with these external systems. So these tools are very versatile in nature that way. Then the second one is the fault tolerance. That is, they fail gracefully. They give an error message back to the agent, and the agent can again retry a number of times given whatever error message has been provided back by the tools. So they are very fault tolerant. And then there another feature which is available for the tools is the cross agent caching, wherein same type of repeated number of API requests, for example, or similar kind of requests are not done but actually cached inside the tool, so that whenever the next same kind of request is repeated the next time, in order to using the again tool, for example, to make an API request, it uses the result which is already cached. So this limits the rate, the number of API requests, and thus saves the cost also. And the results are faster because it is using the cache saved results in order to deliver the whatever has been asked for. So tools are very important feature which is available to be used with the AI agents that can help the task getting done. Hi, in this video, we'll see what is a mental framework before we even start to create AI agents. When we are creating AI agents, we have to think like a manager. Suppose that you have an opening of a marketing intern in your team. First of all, you would like to think what I would want this marketing intern to achieve. What is the goal? And then second is what steps needs to be done by this marketing intern in order to achieve that goal, right? So here the role is the marketing intern. The goal is the output that you're expecting this marketing intern to deliver. And the tasks are the responsibilities, the steps, the processes that this marketing intern would follow in order to achieve the goal that you have defined for this role. Hi, now let's get into some action. Creating AI agents. But before we go into the actual code, let me share with you a few resources that we will be using in the following lessons. If you're not familiar with using the Google Colab notebooks, let me show you how to reach there. And also I will be showing you the environment variables and the utils.py files, how they are going to mount on the Google Drive in order to be used in the Google Colab notebook. And the third thing is the LLM that you will be using, either OpenAI, Hugging Face, or any other model, how to get the API key or the token for that if you're not used before. Hi. In order to run the Jupyter Notebook code on Google Colab, go to collab.research.google.com and log in with your Gmail ID. Once you're logged in, you'll have a display like this, and make sure that you import all the files provided along with these lessons on your Google Drive, and you're able to access those particular files over here in the Google in the Google Colab notebook. Okay. Now, a few things here. Once you are logged in into the Google Colab using your drive, and you have mounted your drive, you can mount your drive from here or using this part, small code drive.mount on content.drive. Then you will be able to see all your drive's content under my drive. Okay, under content, drive, and my drive. And if you're not seeing this folder structure first, you will have to actually go here and then browse the folder structure in order to see this. Now, before running the AI agent code, other two files that you have to import in this particular content folder is these two files, .env files and utils.py files. So what these files are doing is, environment file is actually storing all your environment variables, like all your API keys and secret variables that you don't want to expose. And utils.py field is actually reading these environment variables and providing you when you're accessing directly those files in the code, right? So I'll just show you how these files actually have, look like inside, and I also will be providing you these two files in order to import them here. When you're importing this, when you're actually uploading these files here, then you will have to grant access to Google, to this particular notebook. For example, you are using this particular Jupyter notebook, research write blog post.ipynb. So you will have to provide access to this particular notebook in order to access your Google Drive from here. So all these permissions you will have to provide, then only you will be able to upload these here. And also another important thing to note is that when the session, so right now this particular session runtime is connected, and when you close it, right, the runtime and the complete session will be terminated. At that time, whatever files you're uploading here, these two files will not be available the next time you open this notebook. So you have to upload them again into the content folder in order to run this code. So let me quickly show you what these environment files look like. So if you see, this is a copy of the environment file, and this has three keys here. One is the OpenAI API key. If you're using the large language model API endpoint for OpenAI models like GPT-4 or GPT 3.5 Turbo and so on, then you have to use the OpenAPI key. If you're using the inference endpoints for any of the large language models from the Hugging Face Hub, the open source LLM's inference endpoints, then you will have to use the Hugging Face Hub API token. If you're using some other tools in your application, for example, Google Serper, in order to search the web and so on, so in that case, you will use the tools key, which you can access again from the that particular website for the tool, right? So I can show you a few of the things here. So for the Serper key, you can always go to serper.dev and then create your key there after logging in, and you can paste your key here in order to use that particular key in your code. And I'll quickly show you also how to get the OpenAI API key, also the Hugging Face Hub API token if you're trying to access the models from here. Before that, let me quickly show you what the content of the utils.py file is. It's much clearer here. So this is the utils.py file, which I have opened in the Visual Studio Code. So here, first thing is you're loading the environment variables from under the content folder, whatever environment file that you have stored from there, and then you're accessing, for example, to get the OpenAI API key, you're fetching the environment variable OpenAI API key from here, which will be stored in this particular OpenAI API key variable. And if this variable is not null, it is not blank, then it is returning this variable to your code where you're accessing it. Otherwise, it will just print this message, OpenAI API key not found. Similar to other tokens and keys, similar function, just replacing the variable and the environment variable that is being accessed accordingly, right? So these two files are also provided along with the resources. Now, coming to getting the OpenAI API key if you're not sure about what the process is. What you have to do is you just have to go to platform.openai.com. And then when you go to your profile here, you just go to your profile after signing in, and then you can go to your user API keys. Here, you can create a new secret key, or you can actually use the new version of that, which is basically the project APIs keys. Now, the older version has been replaced with the project APIs key. So you can just create a new secret key here, and immediately paste that particular key. So secret key will be generated, and then you can just paste that secret key in your environment file here, right? And then you will be able to access that using in your code. Now, this is about the OpenAI platform. Similarly, you have the Hugging Face platform, which is basically your repository of many open source LLMs. So for that, you have to go to huggingface.co, and after signing in there, I'll just quickly show you what kind of models are available for using. So these are all the model endpoints that you can use. So for example, if you want to use Meta's Llama, which is by the Facebook, then you can just use this Meta Llama depending upon whatever instruction or what particular model, chat model or instruct model, what particular model suits your requirement. That you can use this particular link endpoint over there, and then you can go ahead and also use your token. So this is the endpoint in order to use this model, and you require a Hugging Face token. So when you go to profile and then under settings, so here if you go to access tokens from the left, here the Hugging Face tokens are there. In order to access these different API inference endpoints. So from here, if you click on create new token, the value will be generated, and you can just paste that value in your Hugging Face API token here. And whatever model you are using, so I'll quickly show you also basically what kind of so if you're suppose using not the with CREWAI, the default model which is used is the OpenAI's model, GPT 3.5 or 4.0. But if you want to use any other model, for example, from Hugging Face, like we have just copied this HF token, then I've just pasted this part of the code here, which is commented, and we can uncomment that when you want to execute using the Hugging Face model, Hugging Face inference point. Here you have to give whatever repo ID. So whatever repo ID you're using, for example, this is for Zephyr, and from Hugging Face S4, I have given this repo ID here. And here it is calling the HF token, the token that we just generated for Hugging Face Hub. That token value will be given here. And what is the task particular to your use case that will be defined here. And this is being called from the Hugging Face Hub, as I have shown you. And again, so this repo ID we can replace with any other model that we are using. For example, if you want to use not the Zephyr, but you want to use Meta's Llama, then that particular repo ID you can copy from here and then go ahead and use it in your code. Yeah, so you can just go ahead and copy this repo ID and use it in your code here, and you'll be able to access that particular inference point. Hi. With all the background action done, now let's dive into creating the AI agents. The first task we are going to dive in is to create AI agents to write, research, and write an article, a blog post. So in this project, you'll be introduced to the foundational concepts of multi-agent systems and get an overview of the CREWAI framework. As we have already gone through the building blocks of CREWAI, if you remember, there are three building blocks, main building blocks using the CREWAI systems. One is framework, one is the agents, the tasks, and the crew. Now, in this particular example, we are defining three agents to write the blog post. The first agent is the content planner, the second agent is the writer, and the third agent is the editor. This will be a sequential process with the content planner planning the content, providing to the writer. The writer will use this content planning material and create the article, and the editor will actually go ahead and edit the article suitable to the requirements. For these agents, the three tasks are plan for the content planner, write for the writer, and edit for the editor. And finally, combining all these, we will have a crew defined with these three agents and these three tasks: plan, write, and edit, with the final output being the article written on the topic of our choice. Now let's go through the code for this particular project. So the first part here is your drive should be mounted in order to access the content from the drive, the environment variables. The second part is this pip install statement, wherein we are installing all the necessary libraries, which is the CREWAI, the CREWAI tools, and the LangChain community in order to access the some other, like for example, LLMs and the other tools. This is the warning control where we are ignoring we are putting a filter for ignore parts where all the warnings will be ignored. Then we are importing from the CREWAI library agent, task, and crew classes. Then as LLM for your agents, here in this code, they have used GPT 3.5 Turbo in the CREWAI example. And we can also access other LLMs for agents depending upon our requirements, and we can show that in a while. Now here, they are using the environment variables to fetch the environment key. So from utils, import this key. And if you remember, we have already uploaded the utils.py file, which is actually reading the keys from this function and providing it here. If the key is not valid, we will get the value in the API key here. And with this environment variable, they are actually setting the model name. What model name they are using for the LLM is being set here. So here they are using GPT 3.5 Turbo. But if you don't want to use the OpenAI API, you can also use the models from the Hugging Face inference points. As we have discussed, you can uncomment this code and comment the above one. And you can use any other model which you find suitable here in this repo ID, and your Hugging Face token you can fetch in the environment variables from here. So this is the code which is used to call the LLMs for the agent creations. Now, once we have set the background environment variables and all the libraries, now it is the time to create the agents. Now, if you remember, the critical attributes for creating the agents were role, goal, and backstory. And it has been seen that LLMs perform better when they are provided a role to play. Okay, so that's why the roles are very important here. And this is just telling that for the planner agent, we are going to write the code, and we given the triple quotes doc strings in order to avoid the white spaces and the new line characters instead of multiple strings. Okay, so basically it is saying that instead of these multiple we are using these multiple strings instead of these triple quote doc strings, because no white spaces and new line characters are accommodated here, but they can be a place for the white spaces here. So we are using this format here in the down code. Okay, so these things will be passed to the LLM. So now this is the planner agent. So here we are using the agent class, and inside the agent class, the role, goal, and the backstory is provided. And this is for the delegation. So we are not allowing this particular agent to delegate its task to another agent. So it has to be specifically mentioned here, allow delegation to be false. And then verbose is true means all the debugged outputs, we can see all the complete logging for the outputs, which is when generated. Now, if you see, the role is the content planner, as we have discussed. And the goal is to plan engaging and factually accurate content on this topic. So this in the curly braces is the topic. So this is actually a variable which will when we run the crew, will be providing this as an input. So whatever topic we provide as an input, it will take that topic and replace this topic variable from here. So this is open to whatever topic you want to provide at the time of the CREW execution. That topic will be placed in the curly braces. All wherever you see the curly braces, these are the variables, and these will be replaced by the actual inputs provided during the CREW execution. And backstory, so again, all these information have to be very clear, very precise, what exactly is expected. So if you just read through this, you're working on planning a blog article about this topic. And then the actual topic will come here. You collect information that helps the audience learn something and make informed decisions. Your work is the basis for the content writer to write an article on this topic. So this is the complete background, basically, what information you want to provide to the content planner in order to achieve his goal. Okay, so just imagine that actual content planner is an actual person in your team, and you are providing him a task of content planning, and you're providing him all the background information that he needs to perform his this task to the best of his capabilities. So this is what is being done over here. Now the next one is the agent writer. So again, writer is calling the agent class with role, goal, and backstory. And this also is not calling any other agent. So allow delegation is false. And all these, elaborate details are provided in order for him or her to, basically the agent, to write the content in a proper manner. Okay. And then third is the agent editor. So editor, again, is the role here. The goal is to edit a given blog post, whatever has been provided from the previous task, to align with the writing style of the organization. So if this is a marketing post for an organization, then you want to imbibe the vibes and the writing style and the brand ethics of the organization into this post. And so this editor will have that responsibility. So if you just read through this, you're an editor who receives the blog post from the content writer. Your goal is to review it, to ensure that it allows journalistic best practices, provides balanced viewpoints when providing opinions or assertions, and also avoids major controversial topics or opinions when possible. And it is also not allowed to delegate because it has to do this work on its own. Okay, so that's why allow delegation is false here. So as you see, this is the creation of the AI agents, the first building block. Now, this AI agents will be passed on to the tasks, right? So now we have to define the tasks and provide them description, expected output, and agent. So these are the three critical attributes for any task that we have seen before. So this is a task planning. So plan task, and it is calling the task class with this description, this expected output, and this particular agent. And we've already created the agent planner above, so we are just passing that particular agent in this task here. And now the description has to be, again, very precise, very elaborate, and to the point. And so if you see here, it is asking it to identify in a very crisp and clear points what is required from this task and what is the output that is expected. So in a particular format, if you're expecting the output or any other details that you want to provide. For example, here a comprehensive content plan document is to be generated with an outline, audience analysis, SEO keywords, and resources. So these 4 points have to be covered in this content plan document. So this is the expected output from this task. So you have to make sure that whenever you're defining descriptions and everything, so these has to be very crisp and clear, as if you're giving this to a human and you would want the actions to be completed in a precise way. So similarly, you have to follow it here as well. The second task is the write task with the 3 inputs: description, expected output, and the agent who is the writer here. So what is the expected output is, so first of all, he would use the content plan. So input is clearly defined here. Whatever content plan has been generated, he will use that content plan. And then he will craft a compelling blog post on this topic. He will also incorporate the SEO keywords which were there in the content plan. And then it is already structured and echoes the brand's voice, right? Expected output is a well-written blog post in a markdown format, ready for publication. Each section should have 2 or 3 paragraphs. So all these details have been now provided to the write task, basically from the writer agent. And the third task is the edit task. As we have seen here, again, editor agent is being provided with clear instructions for description and expected output. So this completes the defining of the 3 tasks. So now till now we have defined 3 agents and 3 tasks using those agents. Then the third thing is to create the CREW. Now, with all these agents and tasks, we will now define the CREW. Okay, and for this simple example, because this is a sequential in order, so we have to be very careful here with the order in which we give these tasks, because it will be performed in a sequential manner. So if we first give edit task, then it will go ahead and first perform the edit task, which will not be complete thing which we actually want it to be, we want it to be executed like that. So we have to be sure of the order in which the tasks are provided here. First is the planning task, the second is the write task, and the third is the edit task. So in the same manner, we'll provide these. So again, now here everything has been combined. CREW is using these agents and using these, tasks created in order to complete the output. And finally, running the CREW. So first of all, you have to make sure that you use this CREW.kickoff method in order to execute, use the CREW class, and then continue with the execution. And now, inputs. Inputs are whatever curly braces, whatever here we give, these are the variables that we have defined during the creation of the agents and the tasks. So here that particular variable was topic, if you remember, in the curly braces. So for that particular topic, what value is to be replaced when the actual CREW is getting executed? So that value we have to give here. Okay. So finally, we will have all the results in the result variable. And another thing to remember is that when the results are provided, whenever we are running the every time, they can provide different outputs for the same input, because these are LLMs and exact same outputs are not provided. So we can get different outputs every time. And one more thing we want to highlight here is that if you're using other models than OpenAI models, for example, if you have committed this code here and using this Hugging Face model code here, then in order to pass the LLM, so this variable LLM has to be passed when you're actually creating your agents, because agents will be finally using the LLMs, right? So you have to give a comma here, and then you have to write LLM equals to LLM. So this will complete your code and will use the LLM which has been defined. Otherwise, it will still point to by default the GPT models from OpenAI. So make sure that you change that part in the code if you're using the models from Hugging Face. Now, in order to execute this code, if you're not sure, so you have to just go to run and then just run this particular code. And after running, we can now dive in order to save time. We can actually dive in the results. So what kind of results, are seen here? I can show you. So this is particular example of the research article here, the research blog post. Now for this, I had given the topic as Paris Olympics 2024. So what results I got, and then let's dive into this, what is happening inside this. So first agent, which is called as the content planner agent, and then it is starting to prioritize the task. So first task is to, whatever has been given to it, the prioritize the latest trends and key players and noteworthy news on, and this is replaced with, the topic was replaced with Paris Olympics 2024. And then all other 4 are similar to what has been provided in the goal of it, right? And then what it does is it creates a CREW agent executor chain. Okay, so this is a chain which we were talking about, that it doesn't directly gives the final answer back, but it creates a chain wherein, or iteration execution chain of thought and then action and then pause and then observation, right? So what is done is it will actually start to create the execution chain, and then inside that, after getting that, it will generate the content plan as the final answer. Okay, so now this is the content plan with this title. Unveiling Excitement Paris Olympics 2024, and with this introduction. And these are the key points. And in the key points, it has covered all the things in detail, like the latest trends, the key players, the noteworthy news, and also the audience analysis. It also given the SEO keywords to be used in the blog article, and also the resources which have been used here to use it, right? And then it finishes this chain. And then this output is being provided to the content writer agent here. After this particular output from the content planner is provided to the content writer, then content writer agent is kicked off, and it goes into its execution chain with these particular tasks which is defined for this particular agent. And then again it goes into that chain, and then it defines the final answer as Unveiling the Excitement with this title. And this now, if you see, this has written the blog post out of that article. And this blog post will be finally used as an input to the editor working agent, which is now starting the task to proofread the given blog post for alignment with the brand voice and for the grammatical errors. And it again enters the screw agent execution chain. And then it actually returns the final article, which is there in order to share the final result. So this will be the final result, which is being shared here after you execute that code. And in order to change the topic, you can give here any other topic of your choice when you're actually kicking off the crew at the end. And you can see here, if you just replace this artificial intelligence with any other topic of your choice, then and run this code, then you will be able to see that the blog post is generated for that particular topic using all the inputs for each task that you have provided. So this is an example of a sequential task execution for a crew using no delegation and a simple agent's input directed to another agent, output directed to other agent, and so on. So this is a simple example of understanding the AI agents and how the CREWAI framework is working in this. Now we are going to drive through another example wherein we will use some other topics from CREW.ai to understand the agents better, where delegation is also possible. Hi, in this video, we'll go over another example of a multi-agent AI system using CREWAI framework. We'll also go over some key elements which help make agents perform even better, like role-playing, focus, tools, cooperation, guardrails, and memory. Now, this example is about a customer reaching to an agent in order to resolve an inquiry about, for example, in this case, it is about some feature from the CREWAI framework. So the customer asks the support agent about some feature on the CREWAI framework, and the support agent will create a response for that particular query, and the support quality assurance agent will actually review that particular result being returned by the support agent, and if everything is fine in that, then it will be returned as a final result to the customer. So if you see here in this, we have two agents, the support agent and the support quality assurance agent, who is the lead and can delegate work back to the support agent in case there is some thing which is not correct in the response which was being returned by the support agent. Now, the support agent also has access to the tool like the Scrape website tool, which can actually go and fetch the content from any website, like, for example, in this case, CREWAI website. So it will fetch the content using a tool from the CREWAI website, and from that content, it will answer the question to the inquiry, and that result will be then passed on to the support quality assurance agent for review. The tasks which are involved here, as you've seen, is the first task is inquiry resolution for the customer, and the second task is the quality assurance review, which will be performed by the support quality assurance agent. And finally, bringing this all together, the crew will comprise of these two agents and these two tasks, and also usage of memory here is enabled in order to showcase how memory can also be used with the CREWAI agents. So let's get started and dive into the code. So the first step is again to install the relevant libraries from CREWAI tools and the language machine community for accessing the LLMs and the other things. Disabling the warnings to ignore all the warnings which are coming in the code while running. And then we import the three important building blocks from the CREWAI framework, which is the agent, the task, and the crew. And again here, this is calling the Open API keys from the environment variable, which we have already stored, and also from it is setting the model name to GPT 3.5 Turbo. We can also set to any other model name that we require along with the key here. Now, coming to the creation of the agents. So the first agent is a support agent. Again, the role, goal, and the backstory is defined, and this agent cannot delegate work to any other agent, so allow delegation is set to false here. So he is a senior support representative in the customer service team, and the goal is to be most friendly and helpful in providing the resolutions. And the backstory is that you work at CREWAI and are now providing support to the customer. So now here the customer is a variable, and this can be replaced by the input that we provide while kicking off the crew. And he is a super important customer for your company. You need to make sure that the best support is provided with full answers and no assumptions. So by setting allow delegation false, we are making sure that it cannot delegate any work to any other agent. But if we don't give anything here, or we give true, so by default allow delegation is set to true. So if we don't give any value here for allow delegation, by default it will be taken as true. That means this particular agent can give the pass on the work to another agent which is better suited to do that particular task. So here this is set to false because it cannot delegate. Now coming to the second agent, who is the lead agent, he is a quality assurance agent. He has to make sure that whatever response is being returned to the customer is a good response, and there is no hallucinations there, or it is the best possible solution for this question. So the goal, role, and backstory is defined here. The role is a support quality assurance specialist. The goal is get recognition for providing the best support quality assurance in the team. And backstory is that you work again at this CREWAI and you're now working with your team on a request from customer. So the customer again is the same which was there with the senior representative, ensuring that the support representative is providing the best support possible. So you have to make sure that the support representative in your team is providing the best support possible, and you need to make sure that support representative is providing full complete answers and making no assumptions. Okay, so this is the agent for creation for the quality assurance. Now, if you see how are the key elements defined is we are defining the role playing. Both agents have been provided a role, goal, and backstory. The focus, both agents have been prompted to get into character of the roles that they are playing. So this is a complete focus is given, on their roles so that they are very clear about what role each of them have to perform. And how is cooperation enabled here is because we are not giving any allow delegation here. So by default, it is true. That means this particular agent can delegate work to the other agent, the support representative, and so that they can work together on a particular given task. Okay. Now coming to the tools. So here, now we can use a tool called the Scrape website tool. So how to import the CREWAI tools? So we have to use the statement from CREWAI tools, import whatever tools you require in your project. So here they have shown the example of SerperDev and Scrape website tool and the website search tool. And also it is possible to create custom tools and then call them here. So you can create your own custom codes depending upon your requirements, and those tools can also be called here. So what are the ways in which these tools can be used? So for example, we're using a website scraping tool in this example. So scrape tool equal to scrape website tool. So this is instantiating a tool from the particular class, and this will scrape only one page URL of the CREWAI documentation. Okay, so here we are just giving one page for the doc scrape tool. From the scrape website tool, we are passing the website URLs. From this website, all the information will be fetched and stored in this particular variable. Okay, and then this information will be used by the support representative in order to answer the query from the customer. Now, different ways to give agent tools. So there are two types of tools that can be used. One is at the agent level. So when we are creating the agent, we can actually define the tool on that particular agent. So for any task, it can use, this particular agent can use that tool, which is defined. And another way is to define the tool at the task level. So when the tool is defined at the task level, then the agent will use only those tools when performing that particular task. Okay, so always the task tool will override the agent tools. So let me show you the example. In this inquiry resolution task, if you see here, we are supplying the tool here. Okay, so this tool is supplied at the task level, and so this particular agent, which is a support agent, has to use only the tools which are provided at the task level. Suppose that if there is no tool provided here at the task level, but the tool was defined during the agent creation, then at that time agent can use any tool which is defined during the agent creation. But since here it is defined at the task level, then it has to use one of the tools which is defined at the task level. And we have to make sure that whatever tool is defined, like required only for the task performing that task, those tools only can be listed here, so that the agent is very focused and does not get confused onto which tools to apply to do that particular task. Okay. Now, so this is the task for inquiry resolution. And again, the details are defined here for the description, expected output, and the agent, along with the tool is provided, which tool has to be used in order to resolve this particular or perform this particular task. So here, since the inquiry is coming, so this particular task will be to get the information from the website of CREWAI and CREWAI.com, and then resolve this query of the customer using that information which is provided in the website, and return that answer to the quality assurance specialist. Okay. Now this is the second task, which is the quality assurance review. Now note that there is no tool which is supplied here, because he is just a lead. He is not performing any actual task. It is just reviewing the task which is performed by the inquiry resolution task, right? But the other agent, support agent. So here it is just having the description and the expected output, and the agent here is a support quality assurance agent. And he is just reviewing the task, and if there is any other issue that he sees with the response, then he can again send the query back to the senior support representative and get it modified, and then again review the answer, and then finally send it out to the customer. Now, creating the crew is again the same thing. Here we are combining all the agents, support agent and the support quality assurance agent. And the tasks again are listed in order of execution. So first is inquiry resolution, and then is the review. But here, if you note that quality assurance review task can actually go back to the inquiry resolution, and some updates can be performed here, and then again it will flow back to the quality assurance review of a final review. Verbose is to enable the logging, and memory equal to true. So this is again added here in order to enable the short-term memory here for this particular task. So as discussed, there are various methods in which memory can be instantiated. So by default is a short-term memory, but then there are other types of memory like the long-term memory, the entity memory, and the contextual memory, for which the details we had seen in the past lesson. One more thing to note here is that when you are using the models other than the OpenAI models like GPT, if you're using setting the memory equal to true here, then you also have to give the embedder function for the embeddings separately, which is defined in the CREWAI documentation. Because if you don't give the embedding functions here, by default, OpenAI embeddings are used in order to save the data into the memory, like the Chroma database. And then what happens is that you will get an error saying the OpenAI key is not available because it is using the OpenAI embeddings function. So make sure that if you're using the model other than the GPT OpenAI models, the embedder function is defined here for the embeddings. So that said, now we are ready to go ahead and running the crew by executing this input. So here the input is given as a key value appears, if you see input equal to input is a final thing which is passed in the CREW kickoff, and the result will be saved in the result variable. Now, what is the input? If you see in the above code, wherever you have seen the role, goal, and the tasks performing, the customer was in the curly braces, the person was in the curly braces, and the inquiry was in the curly braces. So these three things are the ones which are being passed as inputs. The customer is passed as deep learning AI, person is passed as entry NG, and inquiry is I need help with setting up CREW and kicking it off, specifically, how can I add memory to my CREW? Can you provide guidance? So this is the inquiry which is being posed to this particular agents, and then the result is saved in the result variable. Okay. Now, when this code is executed, let's go over and see what the results are seen. Okay. So if you see here, so the first is the working agent is a senior support representative, and he is starting the task, which is defined in the task that this is an important customer who has reached out, and make sure to provide him the best possible answer. Then it enters into the CREW agent execution chain. Okay, and then if you remember, we had passed it on a tool. So now it goes into the action mode here, and then using the tool, it is performing this particular action, which is the read website content, and this is the action input. So wherein we are for the input, we are providing the URL of the particular website which wants to be scraped, which we want it to be scraped. So this is the CREWAI.com website URL, which is sent as an action input here. And if you see here below, this is all the content lines from the CREWAI website, which is now being saved here. And then this is the final answer from this particular task, which is created by the senior support representative. Okay, specifically to add memory to a CREW from this particular details, this answer has been created. Now, after that, what happens is that this particular agent passes on whatever result it has been created to the support quality assurance specialist, who is the lead. Okay, and now it is his responsibility to review this answer and seeing that all is good here and there is no other missing information. Okay, so now it enters into the new CREW execution chain. Okay, and he says that I need to ensure that the response provided by the senior support representative is comprehensive, accurate, and meets the high quality standards, and so on. Now, again, if you see here, what is the action and the action input? Okay, so action is delegate work to co-worker. Okay, and the action input is co-worker here is the senior support representative, and what is the task is review response drafted for deep learning AI's inquiry. And the context is ensure response is comprehensive, accurate, and adheres to the information. Okay, so again, one more session of review happens, and then this is the final answer which is being provided to the customer. So here, if you see here, all has been reviewed, and this is the final answer which is provided as a set of statements, creating a CREW and adding memory to the CREW. So this is now being reviewed, and this is how the flow goes on. And finally, you will have this answer sent to the customer. Hi. So till now, we have seen how CREWAI framework can be used to create multi-agent AI systems using low-code. If you want to explore further, let's visit crewai.com, and you can see what kind of documentation is provided here. So all the concepts which we have seen, you can go into the details of how these concepts work together again. And these are some how-to guides if you want to dive deeper into creation of AI agents. And there are so many things other which is given here, using sequential and hierarchical processes at the CREW level, connecting to different kinds of LLMs. All kinds of sample codes are provided here in order to make it easy for you to customize your code, and customizing the agents, and also forcing human input before the execution, before the final results, and also many other things like agent monitoring. Finally, at when the agents are executing, what kind of monitoring is provided using agent ops and langtrace and so on. So there are so many other things which can be explored here further, and you can deep dive and actually create enterprise grade AI, multi-agent AI systems. If you want to explore further examples, already we have covered two, but there are many other good examples which are provided here on this docs for the CREWAI.com, and you can just explore further and play with all of the examples and strengthen your learnings for this particular a great tool for creating the AI agents. There is also an option of chatting with their docs if you want to just use their docs in order to answer questions which you have your difficulties facing while creating your crews or your code. Then you can actually use the crew AI assistants and answer your question ask your questions here and directly get the answers to resolve your queries which you are facing in creating the AI agents. So this is a very good feature which is provided by them, and you can make use of this in order to go ahead and creating good systems. They also have a Discord channel, and then there is CREWAI Plus also coming, which is in beta right now for enterprises. Here they have given the option of deploying your multi-agent AI systems, and also many other features which are available at this platform apart from deploying the enterprise grade multi-agent AI systems. So I hope this tutorial was helpful in giving a brief knowledge of the concepts of the CREWAI framework, of the AI agents in general, and some deep dive into what kind of efforts goes into creation of the AI agents. And I would encourage you to go into the CREWAI website and look into more details and do some hands-on work in order to get hold of the concepts, and let's create AI agents together and keep learning. Thank you.